Alright, so now that we've talked about rocks in general and common rocks, we are now going to get into the nitty-grittiness of it and just talk about igneous rocks. So igneous rocks form when molten, hint, 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 start filling in your notes, melted rock, this can be magma or lava, and it cools and hardens, also known as solidifies, and makes a rock. How do igneous rocks form? Well, you can look at a piece of granite and obsidian. Both of these are types of igneous rock, but they look very different, which is really weird. The texture is what we can start to look at in order to identify them. Granite is actually coarse-grained because we can see the mixture of the minerals in there. And obsidian is fine-grained because we actually can't see the mixture of minerals in there. It all just looks black and shiny. Which one is not made of crystals? Food for thought. Both are igneous rocks. They're both made of similar minerals. And so what can you infer about how and where each were formed? So what do you think of how each one were formed, and where do you think each one of these were formed? Because both of them are igneous. Alright, so igneous rocks, they were probably the first rocks on Earth, even though they're not the most found rocks, but they're probably the first rocks that were here. Igneous actually means fire, which is kind of cool because they have to do with volcanoes. So you can think of ignite when you hear igneous, because ignite, fire, volcanoes, all that different kind of stuff. So you need to label on your sheet where the lava and the magma is. So where do you think these arrows are pointing towards, which is the outside of the volcano? Well, they're actually pointing towards lava, and therefore the magma is actually inside of the volcano. Okay, so as soon as it comes out of the volcano, it is now called lava. The inside of the volcano is magma. And you can put magma at the bottom too if you want to. Alright, so the different types of igneous rocks, the first one is called extrusive, and this is from lava, which is on the outside of a volcano, and they are fine-grained because they cool very quickly, so you can't see the mixture of minerals in there. An example is basalt, and this is the most common extrusive igneous rock. This type of rock, basalt, is especially common in oceanic crust, which is important for you to know when we start talking about plate tectonics and how those form and collide and kind of run into each other. The second part is intrusive igneous rocks. This is the second type, and they are formed from magma, which is inside of the volcano, and they are coarse-grained because they cool slowly, so you can see the mixture of minerals. Your example is granite. So your countertops are actually formed from the inside of volcanoes, which is really kind of cool. So you can tell your parents, hey, did you know that we have rocks from volcanoes in our kitchen? Which is kind of strange. Granite is the most abundant igneous rock, even over basalt. And it makes up most of the continental crust. So again, you need to know that, especially when we start to talk about plate tectonics. And it forms in the core of many mountain ranges. So if you dig deep below mountain ranges, you will find a lot of granite. In igneous rocks, you can find a bunch of different minerals. Some of them are felsic, which is light-colored rocks. It's less dense, has a lot of aluminum, potassium, silicon, and sodium in it. And one of the examples of this is granite. You can have mafic as well, which is the dark-colored rocks. And it has a lot of calcium, iron, and magnesium, and that is actually basalt. Okay, so felsic, probably an intrusive rock, and mafic is probably an extrusive rock. You can make a double bubble or a Venn diagram on the back of your sheet if you have room, or on the front, about basalt and granite. Okay, if you need to see those brain pops, you can search online with the username is ecob and the password ecob, so that way you can see the differences between the two. Make sure that you include intrusive and extrusive, which one is which one is coarse grain and fine grain, the minerals that make up both of them, like the mafic and the felsic, and color, and if they're dark or light colored, and the amount of silicon in it. Alright, this type of graph you will probably see on your assessment, but the way that you can read this is, let me see if I can get a laser. There we go. The more you go this way, the more light it's going to be, and over here is the darker rocks that you will find. So basalt is over here where it gets darker, okay, and it's also in the fine-grained section right here. And then granite is down here with coarse-grained, and it's also lighter in color down here, okay. And then up here is where it'll talk about the percent of volume, so kind of how dense it is and things like that. We know basalt is not very dense at all, and granite is a lot more dense than that. And there's a couple of different rocks on here that you might be familiar with, like opaline, gabbro is on here, quartz is on here too. Alright, so some questions for you. What is the most common igneous rock? Not just talking about extrusive and intrusive, but overall, what is the most common igneous rock? That would be granite. Why does pumice float in water? It came from an explosive volcano, so it had a lot of trapped air bubbles, so its density is less than 1, so therefore it would float in water. Why does lava cool more quickly than magma? So you have to think about where lava is and where magma is in relation to the volcano. The lava is outside of the volcano, so it's exposed to the air or water that is in the air, so it cools a lot more quickly. What determines the texture of an igneous rock? Well, you have to think about the two types of igneous rocks, how fast the lava or magma cools, and if the volcano is explosive. A batholith forms from a large magma chamber that slowly cools deep beneath the Earth's surface. What type of texture is this igneous rock formation most likely to have? So you need to think about, okay, so if it's forming and cooling deep beneath the Earth's surface, what type of rock that is, and then you need to think about what type of texture that type of igneous rock has. So, if it's forming beneath the Earth's surface, then it would be intrusive, and you need to think about what type of texture intrusive rocks have, which would be coarse-grained. Hopefully you got all your notes. Make sure you bring them to class tomorrow. Have a great evening.